A minute. Anyone get a chance to get outside today? Yeah, really nice if you get the chance. Yeah, very, very nice. Good to go? All right. Hi, everyone. How's it going? I'm Marcus. I work for Edge and Node. I'm working in dev relations and developer success. And welcome to this presentation on file data sources. So who here so far is aware of the graph, building with subgraphs? Okay, pretty much everybody. Okay, anyone here who's not? Everyone, awesome. So I have the beginning of this presentation for a little bit of just introduction to the graph. Since you guys are already into that, we'll just go through that pretty quick. But let's get into it. If anyone wants to have the repo that I've built for this educational seminar, please go ahead and scan this. This is just for your reference. We're just going to walk through this repo today, just showing you exactly what I've built for you guys to go ahead and clone. And then from there, you can build on your own and tinker with and just see how the mechanics work with file data sources. Once I see all phones down, I will continue on. Awesome, cool. So what we're going to do, like I said in the beginning, I went through I'm going to go through an overview of the graph. I'll go through that relatively quickly. Also overview of what subgraphs are, and then really the meat of this is file data sources. And we're going to get into this and just going through the code, what this means for you. And then that's it. So really quickly, the graph, the blockchain itself is write optimized, which means anyone is able to just simply put data in a disorganized state into the blockchain, which we love to have that type of availability to everybody. However, with that type of organization, you have to index it. So there becomes essentially a read issue where we have so much information coming in the write, and then the read also has a lot. So if you're actually using any type of social media, for example, if anyone's built any type of, anyone posted anything on social media recently, you're actually able to have a lot more read from that data as opposed to just a single post of write. Right? So we see that all the time in blockchain. And in Web 2.5, of course, there's centralized indexing, which is a solution. It does work. However, if any of that does happen to potentially go down for whatever reason whatsoever, we're unhappy. So one thing that the graph does provide is a decentralized indexing solution. And a single bit of data, single point of data can go to all of these different nodes around the world and can be provided to your front end. So should any of those indexing nodes go down, that is the graph. Okay, so really quickly, overview. And the graph decentralized indexing and querying protocol. We all know this at this point. Let's keep on going for the presentation. Subgraphs, we are able to actually send instructions to indexers around the world, and they are called subgraphs. And they are customizable. You guys are able to build with these and tinker with these and customize your data how you'd like. And they're very much valuable because they exist in the ecosystem. And this is kind of the on-chain data that we've been working with blockchain. And the devs are swimming through this data all the time. And now that we have off-chain data, there's even more data that we're swimming through all the time. And then when you have subgraphs in action, you actually are able to organize that data very, very effectively. So that's really high-level overview of subgraphs. And for those of you who are already building subgraphs, you're already familiar of this shape of the data when you're actually working with your repos. You have on-chain data, and then you can define those instructions really from a high level at the subgraph.yaml, really kind of the shape of your subgraph. Then you organize the logic and the mappings. And then from there, you have your schema.graphql to send your queries as kind of organized buckets to actually get your GraphQL queries. And this is the part where they're valuable. This is the ecosystem. This is the marketplace of which each subgraph can be valuable for other people because they are permissionless and anyone can build and anyone can publish a subgraph. Let's get into file data sources. So right now, this little infographic that I built, you can see the front end sending write to the blockchain, and then you read it to all the indexers who are organizing that data and then providing it back to the front end. Now we are on off-chain. So we have IPFS, and we're able to get all that information and then also send that to the nodes for organization and indexing. It's a really powerful, powerful new use case for having off-chain data being provided into your subgraphs. And we'll talk about IPFS, which is currently supported right now. It's going to be expanding to other different off-chain solutions coming up, but right now let's just focus on IPFS and the structure of how that's done. So, yes, mind-blowing. I think that's pretty cool. So why would we want to do this? Well, we're going to get into tinkering how to do this. We got builders in front of us here, so I want to go into how. But let's just go ahead and highlight this blog post. If you guys haven't had a chance to read this blog post, it is fantastic at giving in use cases of combining on-chain and off-chain information into a subgraph. This is written by Craig Tudorow. He is one of the developers working on the graph. And it's really great post here. So go ahead and highlight that for yourself. And as we dive in to this, let's just get a high-level overview of the file data sources that we're going to build today, or at least walk through. In today's workshop, we're going to keep it pretty simple, and we're just going to look at an NFT subgraph. We're going to look at NFT metadata and also combine that with on-chain data and see how that goes. How is the information getting triggered? How is the information actually going around? How is that brought into the GraphQL queries? And this is really the high-level overview of how that happens. First, there's an on-chain event and a smart contract transfer event. We're going to be looking at that, and it'll trigger a new file data source template. And that template is going to be eventually finding that off-chain metadata, which then pipes that into your subgraph itself. The off-chain metadata will be found by the new data source template, by the new file data source template, and then from there you'll be able to have that populated in your GraphQL query. That's really high level. Let's keep on going into this. I just went through OpenSea and I found an NFT. This is Beans Official. And really this is what we have. We have this transfer event coming through on-chain, and then this is the metadata that we want to bring in from the IPFS, So let's get into, like I said, this is the repo. We're going to walk through this all together, seeing how this works. Any questions so far before we dive into the code? Making sense? Love it. Awesome. This is also a little bit more reference detail for you in the slides. Feel free to jump in if you would like in the future for a little bit more on this. Okay? Okay, let's walk through. Okay. Oh, this is the Arc browser, isn't it? How do you change tabs in the Arc browser? This is a fancy browser. There it is. There we go. I'm on the wait list for it. It's public now? Oh, good. Okay, so let's start with our subgraph.yaml. Oh, new tab created. Is that right there? Oh, let's see. I need tabs here. Could you help me out with this tabs? I have not used Arc. Just Brave? Okay, let's just do Brave. Okay. There it is. Okay. Yeah, we're having a little bit of issues with my computer. For some reason, it wasn't able to show on the projector. Okay, let's go through here. Let's start with subgraph.yaml, really the manifest of our subgraph. Can everyone see that pretty well? Yep, cool. Okay, so when I initially deployed this smart contract, this was the smart contract address. I used the graph CLI to populate. It automatically populated the start block. And it had lots of different entities that were automatically auto-generated from the events coming from that smart contract. I erased those because all I really wanted to create were just two entities. I wanted to know about the token itself, and I wanted to know the owner. Very simple. That's all I really wanted to know. And then all I'm really looking for the on-chain information, I'm looking for a trigger. So I don't really need all the events and all the handlers to be effective. I just need a single one. I need to look for the transfer and the handle transfer. Now, once that transfer is emitted from that smart contract, the handle transfer event will actually trigger to actually then create this template to start finding that. This is the data source template right here called the token metadata data source, where we're bringing in and we're looking for that metadata coming from IPFS. Anytime that is going to be triggered, the event right up here is going to be triggered. You're going to have a new template coming through into your subgraph, that is going to be able to then populate this token metadata information. Okay, this is the high level of just naming of all the different operations that are occurring in the subgraph. And really, one thing I want to highlight in this file here is that we are separating from the very beginning the on-chain information and the off-chain information. We don't want to actually cross-reference and kind of cross-pollinate, if you will, having the on-chain entities and off-chain entities really coming to the schema separate. You're welcome to link in the schema and actually have this one-to-many relationships if you'd like, but making sure they're separate here is important, just to make sure you're not mixing and matching. Okay? So any questions here so far? Cool, cool. Let's go into the next one, where I like to then go into the mappings. And here we go. So I put some documentation in here for everybody if you'd like to read through this. But essentially we're bringing in I like to rename things as transfer event, that we know we have the event here and the templates. This is from the on-chain information. And then we have the schema from the GraphQL being brought in. These are the three things that we're really working on: the user, the token, and then also the token metadata. Those are the things that we want to populate into our GraphQL. And then here we have the token metadata template. And then we're going to be able to find the token metadata through this templating. So really, in the very beginning, you're going to need the IPFS hash. In this instance, I hard-coded it right in. There is an example later in this presentation where we can have it dynamically to be generated, but just for this presentation, just hard-coded in. And then we have this handle transfer event. We're looking at the on-chain event that's coming out right there. And we're beginning to say, okay, well, what information do we need to actually have on-chain information into our GraphQL schema? And then how do we get that triggering of our template to go searching for the IPFS metadata in parallel? So what we have here is a new entity, a new token entity, and we're populating it from events on chain right there. And then here's where we start to look at the actual IPFS metadata. And we're starting to look at the file structure. So you can see right here, we want the token URI, and this is right here, the beans metadata. If you go into the IPFS, let me actually see if I can pull it up. It was there on my computer, but it's not here. It's okay. If you're looking at the IPFS, you need to kind of programmatically put in the actual shape of the actual HTTP, the actual endpoint. So the beans metadata right there. And then you actually add in the token ID at the end. So it's actually being brought in by the events. So it's token ID 1, 2, 3, 4, 5 being brought in, and programmatically put in. And then finally from there, you have all the information to then actually create your metadata template. You have all the information to have the search execute with the file data sources right here. You just pass it right in. So from there, we'll have a little bit more housekeeping to do because I do want to have the user information in here. You're bringing in the user entity, and then you're loading that in if that exists. And all I really want to have is just a reverse lookup from that user and seeing if that's possible to say, hey, what user has what tokens? That's all I'm doing with this right here. So finally, we're getting into the file data sources where we have the actual information. We have the token metadata template, and that's the templating being created. We're passing in that information from on-chain. And then now we've passed that information, and now we have to handle it. All right, boom, file data sources has been created, and we're getting that going right here. So we have new token metadata, and we're getting that from that token metadata up here. You can see that's the template being created. And you can go to the subgraph.yaml to see that execute right in there. So from here, it's just simply gathering the information from the IPFS metadata. Let me go into the slides here. Where's the slides? Arc browser. I want to find the slides. How do we go back? There they are. There we go. So you have to be aware of the, where is it? Right here. Being aware of the shape of the metadata's data right there, where you can see there's, if I can zoom in here anymore, it's really tight, unfortunately. The trait type, the value, really zooming in as best you possibly can and then iterating through that information is all I'm doing at that point. I'm literally just grabbing that JSON information, turning it into an object, and from there going through one by one, and then populating the entity. So we'll go back to Brave here. Let's see. There it is. So yes, I'm just grabbing that information and I'm just going through and I'm grabbing the image, I'm grabbing the name, I'm grabbing the attributes, and I'm assigning it to the metadata. And from there, assigning it, to the entity. and then we're just checking to see if it exists in there. Assembly script likes to have null checks, and we're once again assigning, and then once again, we're grabbing it, assigning, and looping through. So from there, you're going to be able to have a subgraph. Let's go back to the presentation. Let's see, full screen. Okay. There we go. You're going to be able to have a subgraph that you're able to go through. Unfortunately, I wish I had that. Had all the tabs pulled up. Okay, that's fine. I had a subgraph all pulled up and ready to go on my own computer, but unfortunately I don't have that right now. Unfortunately, okay, so when you actually are able to send out that information and actually gather that information into your subgraph, you can send queries to that subgraph. Just know that when you are sending it, you can actually take that information into the subgraph itself and look for specific locations of metadata, specific locations of the on-chain information, and then go through those GraphQL queries as you'd like. With the subgraph itself that I've pulled up here for you guys, you are welcome to go through this and say, okay, well, if I want this information, let me go ahead and look at how this is organized in the schema. Now, this is all the way from the beginning when we defined our entities. We had the token and token metadata. Those are the two big ones right here. We have a token metadata that is referring to this right here, this entity. And just going through, you can see this was all populated from the mappings. And then the reverse lookup from the user to see who is actually in ownership of this token and the metadata itself. Now, as you can see, this token metadata is separate from the on-chain information, and that's going to be useful for you guys, just making sure that things are organized. One thing I did want to highlight for this is a full text search. If you're able to actually have full text search with any type of metadata, it is awesome. And I just put this in here for you guys to play with, because metadata many times has full text. So if you want to use that feature with subgraphs, go ahead and just deploy the subgraph as is, and you can search for all of the metadata that you'd like with just a text search. And that's a really, really nice thing for your information. So let's go through an overview of all of this. If you know your event that you're looking to trigger, and then you know the IPFS metadata and the shape of that JSON file, you can link the two and have them interact really well together. Just having them search in parallel, the on-chain information is being searched for, the off-chain information is being searched for, all of that being piped into your schema. Like I said, there it is, on-chain events trigger the IPFS file search in parallel. The first time you deploy this with the file data sources, it'll take 20 to 30 minutes to actually gather everything, so don't worry, just give it its time and it'll come in. And then please use full text search, it's pretty awesome. Like I said, next steps for this, read Craig Tudero's blog post on this for really other use cases beyond NFTs. Really cool part he brings in here, data edge contracts. This one kind of blew my mind. Such a simple idea. Essentially what you're doing is you're sending information, just a message, to a smart contract that's very, very basic, and it's passing it right through as an event, and it's dynamically generating that information. So if you want any type of hash to be dynamically generated from that you want to pass to that smart contract, it'll emit it as an event, and it can get your subgraph just spinning up with lots and lots of different hashes, as opposed to this subgraph, which only did one hash. So this is a really cool, simple idea, and he brings it up into that post. A few previews here. We have graph node 0.32.0. In this instance, we're having on-chain events triggering a data source that is off-chain. In the next graph node, we're going to have off-chain data source triggering an off-chain data source. So it's really, really cool use cases that could potentially come up. And then after IPFS, we're going to be supporting Arweave, which is really, really cool. All right. So if anyone wants to scan here, this is the presentation on file data sources. So I hope you guys enjoyed this. And you guys are tweeting regularly, see a phone up. And if there's any questions, of course, I'll be happy to take them right now in understanding file data sources and really just getting tinkering. The repo has 3 different learning opportunities for you guys to just jump in. If you just want to deploy the repo as is, you can get working. And there's 2 other options for you guys to start tinkering and trying to figure this out on your own, okay? If anyone wants to join the Graph ecosystem, we got jobs, network roles, community, more than welcome to take a look at that. So any questions from anybody? Thank you for joining me on this presentation.
saw in your schema for GraphQL, there was for the templates, there was trait type 1,
Mhm.
trait type 2, trait type 3. Is that because we don't know the traits beforehand? Can we name that like, whatever specific traits we care about, or what's going on there?
That's a great question. So what I wanted to do was show, I had a tab pulled up with all of the, basically all of the IPFS data, and you could see it. It was simply, that's the way it was named in the data at IPFS, and I just copied that naming convention into the subgraph, but you're free to name that however you want. It was just simply, I wanted to take the information from IPFS and pipe it into the subgraph and not have different names. Yeah. Yeah.
For now, just support IPFS, right?
IPFS currently, yes. IPFS now, Arweave next. So yeah, did that answer your question? Okay, awesome, perfect. Well, I'll be around for a little bit more if anyone wants to come up and we can talk and I can look over your code and we can just get building together. Thank you so much for joining me and have a good rest of your day.